Hello friends, welcome back to the channel. I am making this video at the request of one of my channel subscribers, and this video is about the Rust Async, and we will understand what is async and why it exists, when to use and when to not, and we are going to check these simple the examples, coding examples. So the first thing is, what is the async, Rust async? Rust async means like doing some kind of the work without blocking the thread. I'm repeating it again. Doing some work without blocking the thread. So normally when your programs runs slow, like the maybe the network calls or the database operations or the file input output operations or sleep or the timers, then the entire thread waits. But async lets Rust say this operation is slow, pause it, I will come back later, meanwhile run something else. Okay. And one another thing which is most people get confused and by their saying that async, like combine async with the parallel. Rust in async, the Rust async doesn't mean parallel, it only means the non-blocking. Okay. Also, why it exists, I will give you the some a real example. Let's say you have a server handling the 1,000 users. So every request, like if a user requests, and then you're on the it will wait on the network and block the threads. So if this happens, it means you need the thousands of the threads, which will be a memory explosion. Okay. Also, what are the advantages of the async Rust? The async Rust async, when to use and when to not. Okay, so the for the better performance of the input output operations, for the heavy input output operation like the network calls or the file input output or the database is called, sleep or the timer, you should have to use the async. On the other hand, when you should not have to use the when you should have to avoid the async, the when there is a heavy CPU workload, like the mathematical like algorithms kind of a stuff, or the image or the video processing, then you should not have to use. Why? Because the async doesn't make your CPU works faster. Okay, it's the simple thing that async doesn't makes the CPU works faster. Okay, so let's just start. We will check the some code examples, and I think by coding some examples, the thing will be more clear. And also one more thing, which is the important one. And the Rust itself doesn't execute the async code. You can define the async code in Rust, but Rust itself unable to execute the async code. For that, you should have to use the Tokio runtime. There's a crate available, one of the most popular crate called Tokio, which will be responsible for your the async operation handling. Okay, and first thing, I think we should have to add the Tokio. Let me search for the. You simply have to search for the Tokio crate, and the first link will be of crates.io. You simply have to check for the dependency, and I think we will add it to the Thomas. Okay, let's get it added. Let's save. Okay, any other thing we need? Okay. So let's define the main function. So there's one thing, like for the async part, we with the before the fn keyword, we need to add the async. It means the function is async now, and we are using the Tokio. So for that, we need to add the attribute which is the Tokio and main. Now this is the Tokio runtime. This main function is async function. So let's create the example. Let's say one by basic async function, and we have to use the async then function. Let's say we have the say hello, okay, and we can say that hello from the async function. Okay, this is a simple function, async function. Now we have to call this. Let's first add the basic, or we can say that example one basic async function, and we need to add that. Okay, we have to call this hello. Okay, so this function will not it will not execute, and I will explain it. I think I have to explain the future as well. So let's just test for this. We have to use the dot await, which means the function is async, and for the async function you should have to use the dot await, and I will explain it later why we need that. Okay, so let's test this first. Now it's compiling because we have added the Tokio. Great. Okay, so it's executed. So example one basic async function, and hello from the async function, it gets executed, which is working perfectly fine. And now let's say the example two. With the async you should have, you can easily add the delayed kind of a thing. Let's say we have the example two, which is called, I think we can say that async delayed. Okay, so the function will be async and delayed greeting also. Okay, so we have the Tokio created. So there is a sleep. We are not going to use from the standard library, the thread sleep. We are going to use the sleep from the Tokio, and we need to use the duration. Duration will be like from, not that, we need the milliseconds, let's say. Okay, and we can say that delay milliseconds. Okay, and we have to use the await. Okay, also one more thing, we need to add the name for the greeting. This will be an string slice, and delay milliseconds will be of unsigned. 64 will be fine here. Hello, let's say that hello, and you can say that after dash milliseconds. Okay, we need to pass the name and delay, not that, name and the delay. Okay, so this is the delay greeting function we have created with the sleep, which is the async as well. Let's add the print new line and say the example 2 delayed delay async function will be fine. Okay, and we have to call the delayed greeting, and name will be, I will pass my name, and milliseconds will be 1000 milliseconds. We have to use the await, so you should have to use the await. And let me run this again. Okay, I'm exploring the Tokyo grade. There's a very good coding example. If you open the grades.io, you will see a very like a better written code example there. Okay, 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 so it's executed example one, example two. Let me run it, clear the screen, run it again. Okay, it delayed for 2 seconds and it will start after 1000 milliseconds. Okay, it's working fine. Now the important thing, the example three, which will is related to the lazy futures. Okay, let me explain what is this. If I There's a crate available for the futures as well, which we don't need right now. But I will let me explain it. What are futures? Um, okay, so the important thing is Rust, like the async returns the futures. Okay, so keep in mind that async returns the future. Think of futures is like if you have worked in the JavaScript, you will definitely have an idea about the promises. Then futures are almost related. It's kind of a same with the like with the JavaScript promises. Okay, and let me say that. We can say that demonstrating lazy futures, and what we can say the async function will be a lazy future. Okay, and you can print that this only prints when updated. Okay, and what do we need to do? I think we should have to return this something from, and also the return type would be a string. Okay, example 3. So let me explain. This is the important concept of the futures or future, right? Okay, it will get clear. We can say that print for the new line, and example 3 will be lazy futures. Okay, so I have mentioned that async doesn't execute by itself. You should have to use the dot await. Let me create the variable called future and now call the function which is the lazy future. Okay. I have it called nothing prints yet. Okay, because I haven't used the dot await, that's why it's the lazy future or lazy future itself will nothing like if like you will define the async function and return anything from that function and if you call that function nothing will happen until unless you should have to use the dot await. Okay, and you can say that okay, so the future created but not awaited. Okay, that's the good thing. A future created but not awaited. And what we need to do? We will define another variable which is result. And now this time, as you can see, I have defined used the variable future, and I have the await variable. And now what we can say? Just simply say the result, or we can say that result. So let's test this. Let me have the line break. So I think we don't need line break. Okay, so example 1, 2 we have already seen it. So example 3 lazy future. So future created but not awaited. Okay, and this only prints when awaited. So it's awaited, then it gets print. So result it returns us the future itself. Okay, So it's working perfectly fine, and I think it will be clear that without just by calling the async function nothing will happen. You should have to use the dot await. Okay. And what else? I think there's a one more important concept, the example which I need to show, which is called the sequential execution and the concurrent execution. Okay, I think for that we will define the example for what we can say that sequential versus concurrent execution. Okay, let's say we have the async function. Async function will be some kind of like a fetch data. Okay, and for that we are going to pass, we have to pass the id, which is the unsigned 32, and return type will be an unsigned 32 as well. You can say that fetching data for id, and we are going to use the sleep again. Duration will be from seconds will be 2, and we have to use the s because again the await function here, the await. And now what we can say that data fetched for id, and we have the id, we will multiply it by 10 and simply return that value, nothing else. Okay, it's not get used. So now we have to use the, so first we will check the code example for the sequential execution. We can say that sequential execution, or we can say that example will be, because there are two cases for the example. For we are going to use the same fetch data for the sequential and the concurrent. I think I can say that for a, which is the sequential execution. Okay, so we have prompt the user, and what now we also have to measure some kind of time. We need the time difference for the sequential and the concurrent execution, and I will show you the difference. There's how much the concurrent is faster than sequential, which is, I think, what we can say. Let's use the start for the instant struct, and we are going to use the now. And let's say we have the result one will be a fetch data, id will be 1. We have to use the await because the function fetch data is the async, and we can say that result 2 will be fetch data again and await, and I think 3 will be fine. Okay, so we have the result 1 2 3 and start time, and then we just simply we can say that sequential results, the first one, the second, and the third one. Result 1, result 2, result 3. Okay, and also we need the time. We need to show the time taken. Time taken will be what do we have? We have the start dot elapsed. So this is the example for the sequential execution. Let's first test the, I think we should have to test the first sequential one. Example 1 2 and 3. So the fourth part, you get the sequential execution, fetching data for id 1, data fetch for id 1 2 3, and sequential results is 10 20 and 30. Okay, and time taken is 6 seconds, 6.00647 seconds. Okay, and so as you can see, the data executed in sequential order, it's in a sequence. Okay, So that the first, second, third, these three results will be executed in a proper sequence. Now let's check for the concurrent execution. We can say that example 4b, which is the concurrent execution. Okay, so let's use the start again and instant now. Okay, okay, there is a one catch in it, and it's for the concurrent and the sequential part. There is one thing called the join macro in Tokio, and also if you are using the future create, there is a, I think there is a join all, some kind of macro like that in that. But we have already Tokio in edit, Tokio created it, so we are going to use the. So what's that join? Let me first add that. We can say that result 1 it returns tuple, and result 3 we have the Tokyo added. There's a join macro. As you can see, we have the join macro. We are going to pass the fetch data. You don't have to use the dot await because the join macro is used for the async functions, and it combined the join macro give you the, like, the possibility of combining the multiple futures together. You have to pass the, let me show you the example first. Let me for the second part 2 and for the other part 3. So we have passed the fetch data 1 2 3 three times. We have called the async, this is the futures, and with the join macro it gives you the advantage of using it, give you the possibility of using the multiple futures together. And what is the advantage, like, because as you can see, this is not in a sequential order. Let's say if the fetch data 2 is called and it wait for some time, then this first or the third will start executing, and it may be finished earlier than second one or the first one. And keep in mind, this is not a parallel thing. Okay, parallel is a different thing. Parallel kind of thing it's parallel works on the multiple threads, it's on a same thread. Okay, it's called the concurrency or the concurrent thing. Okay, so let me we have that, we can say that concurrent results. And also after running this example 4a and 4b again, the 4b for the first time, you will see the clear difference. Now we need to say the time taken, and we have the start dot elapsed. Okay, so let me check the code again, and we have combined the multiple futures together by using the join macro. So let's try to run it. First let me clean it, and so we should have a here start. Let me run it again. Oh, wait a second, let me hit the line break here. So okay, so as you can see, this is the for example, the sequential is run in sequential order, and the time taken is 6.005, and it's a second, 6 seconds. 4b. Now check this part, the concurrent execution, the fetching data for the 1 2 3, and by any chance, like, data fetch for id 2 to first, and then third, and then the id first, last one is for the id 1. So as you can see, this is the concurrent, not in some kind of the sequential order, and the results obviously will be same. Okay, but now check this out, the time taken is 2 seconds. So there is a huge difference between the 6 and the 2 seconds. So concurrent execution is much faster as compared to sequential. And now you might be thinking when we should have to use the concurrent or when we should have to use the sequential. So let's say there is a case like let me show you the code example here. Let's say we have the value, some kind of the user, and there's a get user function, and we have to await it, and then we have the orders, get orders, and that orders depend on that user. So for that user, in this kind of a situation, you should have to use the sequential, because you should first have to get all the users, then you should have to get all the orders which depend on that user. In that case, you shouldn't have to use the concurrent approach. You should have to use the sequential. So this is one minor example. I think you guys will definitely get my point. Okay. Also, I will like push this code and add the link in the description. And I hope you guys enjoyed this video and learn new things. Let me save this. Okay, let me check the code again. I think everything is it's perfectly fine. Okay, we have the example 1, example 2, example 3, example 4, and everything is fine, I think. Okay, so I hope you guys enjoyed it. See you in the next one. Take care. Bye.